All right, good morning, everyone. Welcome to our November quarterly meeting for the Rocky Mountain National Park Agriculture Subcommittee. We looks like we have everyone here for our agenda, so I'll go ahead and get started in sharing that. You should be able to see this now. Just a couple of notes right off the top. As always, we want to give ourselves just a moment to review our guiding principles, so I'll give you a chance to just scan this. This is our touchstone. We come back to this every time and make sure that our why we are here is really clear. So I'll give you 30 seconds just to scan again. I'll just make one comment today. I think on number 3 here, we are really making some great progress. It's wonderful. The second half of our meeting here today will actually be dedicated to those BMPs. And we've got our structure in place, thanks to Bonnie and a number of others who put a lot of time into this. And I'm delighted that we could focus on that really directly now in the second half of our meeting. Okay, so as far as the overall agenda, we'll do some quick introductions and so on as we've done, and we've reviewed our guiding principles. I do want to remind us of a couple of things, just sort of from a logistics perspective. All of your calendars are up to date as far as this meeting today, but with your permission, I'll extend this out through next November as well. Unless there are any objections here, we can continue on this pace. I'll just pause. And is there anyone opposed or feels we need to find another time slot as we move into the next year?
I think it's been working for me, so.
Thanks, Bonnie.
Works for me as well, Brian. So
good. Yeah, I'm really pleased with our participation. It's improved even over the year. So thanks everyone for all your time. Okay, so I'll take my first action item is to extend this out for another 4 meetings through November of 2024. Corin, I have a little spot here for you. Do you want to make a pitch?
Yeah, thank you. So I'm Corin Neidig. I lead resource stewardship in Rocky Mountain National Park, and I was contacted by a teacher at Estes Park Middle School who wants to do a place-based curriculum on she's calling it pollution in the park. And there'll be a variety of components that kind of fit into the earth science, Colorado standards and things like that. And I was talking to her about the work with the ag subcommittee, and she was wondering, it would be great to have someone who could talk to the class about, yes, agriculture is a source of nitrogen emissions, something about what those sources of emissions are, but then also like what are the best practices, what are the different things that different ag producers are using to reduce those emissions, and that's basically what she's interested in. And it could be someone who's, actively running an agricultural operation, who's, involved with the best practices. It could be someone who is, working on research in this area that can provide some of that information. The idea that there's research going on where I think it was, where different kinds of stock are being, actually their belches are being measured and monitored, and their one of the best practice has to do with their nutrition and things like that. Like, I think that will kind of blow the minds of the students that, that managing nutrition in their food source, right, can actually, help the environment, and other of the different best practices that are either been developed or being researched would be great. The other elements of the project or the curriculum, that she does want them to learn about the different sources of nitrogen to the park and how it's affecting, the ecosystem. They will also be learning about, fossil fuel sources and things like that as well. So, and it sounds like this is something she wants to develop and do every year with the student. She's currently a 7th grade science teacher, and she also leads the what's called environmental resilience team. It's a club that meets every week. It's really active. So she's a really great teacher, fun to work with. I may be taking, arranging for a field trip for her to look at the kids to look at one of the monitoring stations. They may do like a lab in their class where they have, they do a fertilizer experiment with either plants, maybe also water, so they're seeing like the effects and things like that. So she wants to tie it into the standards. She has to tie it into the standards, for the middle school education, but she really wants to make it place-based and, something the kids can interact with and understand a problem, but also think about what are the solutions, right?
Well, let's make the ask, Corin. What if anybody's interested, should they reach out to you directly? Is that the best way?
Yeah, reach out to me. You can even let's see, can I find how to get the chat in here?
Yeah, if you drop your why don't you drop your direct email in the chat, and then we'll remind folks as we go forward. So let us know if you do book someone. It'd be interesting to see what that material is and share it back with this team. We'd like to get another generation of scientists working on this problem. So maybe it's a recruiting effort.
Yeah, for sure. And the other thing is like, if there's someone out there that's motivated to actually go up to the school and meet in person, then that's great. But they can also do like Zoom interactions with the students and stuff like that. So you don't actually have to travel up to Estes Park.
Yeah, thank you.
To do it,
I hope we generate some interest. Please reach out directly to Corin. We'd love that.
Yeah, if I could just tag on a little bit there, we just delivered to the 3rd grade class in Estes Park, all 3 of them trout eggs for a trout in the classroom event where they're going to be growing them and then doing the water sampling and all of that and so it might be a good opportunity to hook those groups together in the school.
Oh, thanks, Dave.
Okay.
That's great.
And who
So
just said Dave
there
from Trout Unlimited? Okay,
Yeah.
Dave from
Yep.
Trout Unlimited. Okay, awesome. Yeah, I've also heard about that program. My daughter actually did it. It's pretty cool program.
Go ahead, Bonnie.
just wondering what the timeline is for this, and do you have other people from the MOU agencies or that would be presenting, or is it the teacher that's putting all this together and presenting to the class?
So the timeline, she's a little bit vague. I mean, I think we have, she like starting it in the winter. It depends if she want to go on a field trip, that might have to wait until better weather. But starting it in the next couple months. And then, so the park, through our education program, we already have some materials developed because we actually have a distance learning program that the education team here has provided. But she's looking for like some like real people involved with it, not just like the educator. And so that's why she's, you know, we're seeing if there's someone either involved with the practitioner level or research level who would do this. And then I'd probably give a presentation to, you know, on the ecological aspects of it in the park. So I'd be another real person to them.
Yeah.
Yeah.
Well, thanks so much, Corin. Everyone, please think about this. Use your networks, share the request on if you can, and get back to Corin. So, Corin, make sure we drop your email in the chat if you haven't already.
Okay, great. I will.
All right. One other just general introductory note. We have succeeded now in transferring the administration of our website from CDPHE to CDA. So from now on, in fact, when I distributed the agenda for this, you might have noticed that was hosted in a Google site. That is our Google site. So we're happy to announce that the change of administration is complete, and our contacts at CDA are now able to add and use that. So we'll continue to build out what we have in the future. I'll make sure the calendar is updated with our future meeting sites and so on, and any documents that are shared here will be posted back to that website and available to the public. So I'm glad to announce that that's finally complete.
That's great news.
All right. Oh, go ahead.
I'm glad to hear that. That's good news.
Yeah, it is. It is. I'm glad to be able to say that here today. All right. Our first agenda item up here is Jim. You want to give us an update on the contingency plan and anything else that may really be related in your world? Go ahead, Jim.
Sure. Yeah, this may be quick. No particular new news on the contingency plan addendum. What is maybe relevant to this group related to the ask for co-presenting to the commission next year for the milestone report. Our timeline now for that, I think previously it was as early as like February. There may have been an interim date, but now we're looking more at the May 2024 month of May, just for agency logistics and milestone report development, but also the commission schedule. There's the standing ask for agricultural representative to co-present with us so that they can best be at the table and best answer the agricultural related questions we've received in the past. Well, that's my update.
Great. Anything else from the park or the service? Okay. Anything else from any of our other MOU agencies? I was told there was no updates, but we do have a little time here if there's one update from EPA or others.
Thank you, but no updates from EPA.
Okay. Great. All right. Well, I'm pleased to introduce Dr. Dan Miller, or Dan as he prefers, here from the USDA Agroecosystem Management Research Unit. And if you're ready, I'll stop the share here, Dan, and you can take over. Just hit share screen.
Yeah, that sounds good. Let me see if I can pull it up here. There we go. Can everybody see that?
Yeah, maybe if you go full screen. There you go. You got it. Yep, that helps.
Well, thank you for the opportunity to share some of the work that we have in progress at the USDA ARS. This is kind of an overview of what we're planning to do and what we're just starting. We call it ADAPT. It's a multi-location project to monitor ammonia deposition very close to animal production sites. We know animal production sites are strong sources for atmospheric ammonia. And there's some questions about how much of that actually moves away from the production area. And so hopefully this research project will help us to understand that part of the puzzle. I'm a research microbiologist, at the Agroecosystem Management Research Unit in Lincoln, Nebraska. And kind of ARS research traditionally, and I think a lot of folks know April Latham, and she may have filled you in on some of our research interests and past research that's done, but mainly we've been focused at emissions. And that involves all the different varieties of commodities, you know, beef, dairy, swine, poultry. We also look at manure application and those nitrogen losses and greenhouse gas emissions in that process. And we've been looking at understanding the emission inventories. You know, how much is produced for this particular management practice versus this other management practice. And one other aspect of kind of ARS research is looking at those nutrient inputs versus the output. So what's the balance? What's the loss of nitrogen? And a major focus, of course, is to try and make these more equitable, and that the amount coming in and the amount coming out in the animals is more closely matched, because that ends up costing less for the animal producers, who are major stakeholders. So that's kind of always been our focus, is how do we make things better for the producers. Now, we have done some work in the past couple decades on nutrient deposition from beef cattle feedlots, mainly phosphorus, and that's been some work that's come out of the Bushland research location. They're located right near a beef cattle feedlot, and they've done some work looking at soil phosphorus and how that's increased over time. More recently, April Latham's work is looking at nitrogen deposition from dairies there in Idaho, and she's really forged ahead and done some really good work in those systems. And I understand that hopefully one of the upcoming meetings, you'll hear directly from her about some of her really cool work. So a lot of the work that I'll talk about is kind of on the piggyback of what April has done and started. So I think we have some good shoulders to stand on there as we move forward. So my particular interest, I said I'm a microbiologist, and so you wonder, okay, what's a microbiologist to have an interest in this at all? My particular interest kind of comes from the nitrate contamination issue, and it's particularly a big issue here in Nebraska and other areas where we have a lot of irrigation going on. We know that there's widespread growing issues with nitrate contamination in groundwater. It exceeds the drinking water standard, and there are some risks associated with that, particularly some childhood cancer risks that we see in Nebraska, which is kind of scary. It's very expensive to treat. For instance, here's a little map of the area near Creighton, Nebraska, which is in north central Nebraska. Very sandy soils, a lot of crop production in these areas. The groundwater is very close to the surface, so it has become broadly contaminated. And as these blobs of high nitrogen move towards Creighton, Nebraska, and their drinking wells, they had to come up with $1.3 million for a reverse osmosis treatment plant. And that's a population of 1,100 people. So this is a very expensive problem for small communities, let alone the rancher or the producer that's out there on the land and pulling water up from these groundwater sources, and it's high in nitrate and has some issues with it. So when I came into this particular problem at Creighton, there was kind of the animal producers versus the crop producers were having a bit of a fight, like, well, you're to blame. No, you're to blame. It's all those animals, they stink, they're leaking ammonia, and that's where all this nitrogen's coming from. So my initial project to kind of try and understand and try and educate folks as to how nitrogen moves through systems involved coming up with a nitrogen budget for that Brazil groundwater system. And so this little figure here kind of illustrates some of the inputs and outputs. The little brown layer on top, of course, that's the topsoil, and the blue layer down below would be the groundwater with, of course, a lot of rock in there as well. But basically, I wanted to do some accounting of what are the nitrogen pools, what's coming in, what's moving through, what's coming out. Where can we learn that the nitrogen is the biggest issue, and how can we help manage that? And so, and I tell the producers, the elephant or the gorilla in the room is all this organic nitrogen that's in the topsoil. There's a ton of nitrogen there already. And it slowly goes through, decomposition, mineralization, and a little bit of nitrogen leaks into the groundwater system. And that's kind of the natural background level. And when we go in and we change, alter these systems and start planting crops and doing other things, we bring in nitrogen fertilizer. The nitrogen fertilizer goes in, it helps really, the corn crop grow. You take a lot of that nitrogen off, but it's not a 100% process. You have a certain amount that is pretty much leaks through, and we've been able to establish that with isotopic studies and other things. But a certain percentage of that doesn't hang out. It goes right down into the groundwater in these shallow systems. So the nitrogen builds up in the groundwater. If you look at how much water is there and what the concentration is in that surface layer, and you can just do the math on it and say, well, under an acre of land, there's going to be around 600 pounds of nitrogen in that groundwater. The nitrogen can come out of that and be re-irrigated onto crops, and that's something that producers do. And one of the strategies is we try and have the producers account for that nitrogen that comes back out onto their crop. And in that way, they reduce the amount of their initial nitrogen inputs, because you're adding nitrogen during the growing season when the crop frankly needs it the most. Part of that, of course, doesn't always hang out and get into the crop. It goes back into the groundwater. So you end up having a net loss of maybe 30 pounds of nitrogen per acre. But there's this also, in addition to a low level of nitrogen fixation naturally in the soil, which is quite low, you also have nitrogen deposition in these systems, and there's a range there, and it could be quite large based upon maybe proximity to animal production sites. We just don't know a whole lot about how much nitrogen may be coming in from local sources or even sources from far away. So, the question is what role did animal production have to play in these groundwater issues? We know that the feedlots themselves, they develop a very impermeable layer beneath them so that nitrogen doesn't leach down into the aquifer through the feedlot surface, at least here in Nebraska. The soil conditions and the organic matter that builds up in the manure on the feedlot pens just doesn't allow that. But we do lose a fair amount of nitrogen through ammonia volatilization from the manure that's on the feedlot, and then after the manure is applied in the field, we lose some of that nitrogen. And just doing some back of the envelope calculations, a 2,500 head CAFO, based upon how we know that about half of the nitrogen is lost from the manure, and we know how much nitrogen is actually retained in the animals, and we know how much nitrogen is fed the animals. A 2,500 head CAFO in a year would lose, it sounds crazy, but 220,000 pounds of nitrogen. And that is mainly through ammonia volatilization. We know that it doesn't travel, that doesn't completely leave the system. We know that if you look at some of these systems near feedlots, they actually have a fair amount of nitrogen in the soil. So there's some redeposition. And the question is how much of that nitrogen that's lost may be going right back out into those fields to grow the next corn crop that's going to be feeding the cattle. So that's kind of how I got involved. And I wanted to know what this deposition rate was so I could really understand better about this deposition here for the local nitrogen budget. And the thought being that if we knew what the deposition was, these folks could cut way back on the amount of nitrogen that they apply, save money, and still grow the corn that they want to grow. So I started asking a whole bunch of folks saying, hey, do you have any numbers on this? Does anybody have any data here? I knew April Latham was working on some studies at the time and was starting to collect some of that data for Idaho. but I was particularly interested in Nebraska. And eventually, the problem is if you ask enough people, then they'll start saying, hey, we really need to do this, and we need to have somebody to organize this. Would you try and bring everybody together, and we could form a group to maybe examine this in our next 5-year cycle of research that we do every 5 years in the ARS. So of the folks I talked to, speaking with Peter Batis down at the very bottom, he's our national program leader. He made some suggestions, and I knew a bunch of folks that were doing nitrogen emission type of work or work in animal production systems. And so these folks said, hey, let's form a group and maybe come up with a fun acronym for ourselves, which is how we come up with ADAPT. It's the ammonia deposition near animal production team. And you can see we have a wide variety of folks with various research training in different locations and different access to different commodity groups, and also interests in some folks, for instance, Phil Silva, he looks at methylamines and other nitrogen compounds, not just ammonia. And we also have like Phil, let's see, Kyung Ro, who's involved in modeling, which will become very important when we start developing this project and handling the data that comes in. But another key partner was when I talked to April, and she says, oh, you need to talk to John Walker at EPA. And he'd actually had a couple of papers published about ammonia deposition near animal production sites in North Carolina. And talking with him, we realized this was a guy that we could essentially do what he was doing in North Carolina in some of these animal production sites in the Central Plains and other places. And he was the one who knew what to do and how to do it. So he came on board and has been kind of mentoring us as we develop this project. So as I mentioned, we got a quick something in the chat here. I just want to see if that's a question.
No, you're clear.
Okay, good. All right, anyhow, so we have, these are all the different locations where ARS research is conducted. These are, and so you can see there's a couple sites here in Nebraska, Lincoln and Clay Center's one, but I mean, we're scattered all throughout the US. And so the folks in the ADAPT group come from a wide range of different sites, which is good if you want to try and do some comparisons across different locations. We decided to initially focus on a smaller set to get them up and running, and then we could potentially expand to other locations as well. And so the set of 3 locations we're looking at, one's in Iowa, one's in Nebraska, and one's in the Panhandle of Texas. Of course, out in Idaho, I should probably put a blue circle around that as well, because that's where April Adam is, and she's doing some work there as well. So the objectives for our group were to encourage these collaborations among scientists to measure deposition. We wanted to establish uniform field collection methods and standardize the modeling approach. So we settled on doing this passive ammonia sampler approach, where it uses a fair amount of meteorological data and some biogeochemical measurements of soil and plant properties that go into the stage model to predict deposition on that fine scale. From this, what we'd hope to do is refine those nitrogen inputs into livestock adjacent landscapes. And they could be anything from a local wetland, which might be experiencing eutrophication, to my particular interest, which was adjusting fertilizer inputs to avoid nitrogen leaching at certain sites. But I think one of the things that might be an offshoot and be most interested to your group is this better accounting for ammonia transport away from an agricultural environments. If we know what's happening and ending up local in that local area, we can then understand maybe what's traveling and how to best manage that. Finally, the buy-in from the EPA guy, John Walker, was we could provide this data to them and improve those chemical transport models so that they could really refine it down to a smaller scale and understand it better. So our initial steps was to develop this consensus. We'd use the stage model. There are these biogeochemical inputs, and here's a number of them for you to see. And it's seasonal sorts of input. So we could go out every season and see, okay, what's the soil nitrogen, at this location, and the pH and how much vegetation's here. The meteorological inputs, of course, we have to have that in a much finer scale to really drive that model. So we have the sonic anemometers, and then we're collecting a bunch of other solar radiation data, precipitation, surface wetness, and some other things. The ammonia inputs, which would be kind of the most involved for the folks managing a site, would be a bi-weekly integrated sample using these passive samplers. And I know, and this was something that, speaking with April, she said she had used in the past, and working with John Walker, we could get this to work in our model, in their stage model. But we also needed to collect occasionally, seasonally, or these diurnal trends to understand how ammonia concentrations change during the day. So with all this uniform collection and processing, we could start, really collecting a great data set here. And then, of course, COVID came along. We got delayed, but we're back on track now. But yeah, we could have been, I think, a year or two ahead of where we are now if the darn COVID didn't happen. So these 3 sites that we're looking at, here's a little bit more about what they're doing. The first site is a crop, heavily cropped area in central Iowa near a swine production house. Here on the lower right, you can kind of see where we had some information about the annual or the average wind trends. And that helps us educate as to where we may want to end up putting out these passive samplers. Of course, there's like a micromet site, which helps us collect data. And then, several sites where we'd be collecting some of the soil and plant chemistry data we need. The specifics at this site is they're mostly interested in, and this is kind of where each of our sites has a different sort of focus, which appeals to our, research project. We're not just doing one thing, but we're trying to look at different questions using the same approach. They have a laser system to measure the emission of ammonia from the 2 little swine houses here in the center. So they can actually know what's coming out, and they want to understand what is ending up kind of as a mass balance in this area here, right very close to these production sites. There's a variety of crop production there. There's a corn soybean rotation, which goes into how are we going to collect these ammonia samples. There's also pasture land as well. 2 potential sources at this site, of course, are the swine houses here, but there's also, you can see down here, there's a couple of waste lagoons there's a small town just east of here. And so the human waste treatment goes there. And so that could also be a potential source of ammonia. And we'll be able to piece that out a little bit based upon this array as to how much ammonia is coming from that sources versus the swine production. Their big challenge is that this is a completely private site, which involves getting multiple agreements with all the different landholders, stakeholders to put these samplers out and make sure that we're not messing around with their crop production or animal production or other things like that. So this is Steve Tribune. He's the kind of the local head there on that Iowa site, showing off where he has some of his samplers that will be up quite high, which would be above the corn crop where they need to be to collect that ammonia sample. Site number 2 is located in Nebraska at the Meat Animal Research Center, right adjacent to a big cattle feedlot that's part of the research center as well. And so the goal of that project, which I'm most involved in, is to understand how ammonia that may be coming from this beef cattle feedlot here at the center of the slide, this image, may be impacting this area up here, which happens to be a seasonal wetland, mainly for migrating waterfowl. So for a month or 2 a year, this gets to be a very wet area, and waterfowl stop here along their migrating pathway there in the central Platte Valley. And so we want to understand how much nitrogen that is being produced here may end up here. Now, We have very good access to all these locations. They're right on like little gravel roads or paths that we can drive down and collect samples and get in and out very easily when there's not any water around. But the big challenge we have here is there's 3 primary sources. There's this cattle feedlot here. This area up here is some converted bunkers. This was originally an old artillery munitions plant back during World War II. They've converted these bunkers to producing swine. And so we have a major nitrogen source up here as well. And also there's seasonal cattle grazing. When this is dry, the cattle come in and they graze through this area. So there's some small amount of ammonia and nitrogen entering the system that way as well. The real strength we have here is this is federal property outside of the swine operation site. And the big federal research location down here, there's always folks there that can run out and collect samples. There's folks here that are doing studies at the feedlot. And so we have really good feedlot data on how much nitrogen is being fed, what kind of feed rations are being formulated, and how much is being provided to the animal. So we have nice data coming from this particular location. The third site and I should go back, the second site there was the one we have progressed the most at, and we've actually started collecting some of those passive samplers. We have meteorological stations actually going at all 3 sites collecting data. So we're kind of in the progress of getting these sites up and running kind of full term. This is our third location down in Texas. It's also near a beef cattle feedlot. This is a privately owned feedlot, but over here is the Bushland ARS research location. And here what they're interested in is maybe the impacts of nitrogen from the feedlot affecting this rangeland area over here. So that's what their primary goal is. There's good access to getting in and out. One primary source is this feedlot, and this is the central playa where they have a lot of the drainage from the feedlot. Any runoff goes into this playa, and so they can understand, they know a little bit about nitrogen dynamics in this seasonal kind of wetland area as well. Another nice thing is folks here in Bushland, there's a long history of doing emission, particularly nitrogen emission work, and they have a lot of good soil data already collected. So there's a nice rich background of data here. So in summary, the ADAPT group, we've initiated multi-location deposition projects with EPA input and support at 3 sites, and everything's instrumented at this time and collecting data in the proper manner, which is good. We have passive samplers already collecting ammonia at the Clay Center location. And kind of our ongoing challenges right now is developing and standardizing the data pipeline, in that we're evaluating and implementing all the same biogeochemical analysis methods, but we wanted it to populate into one data stream to the modelers. Speaking of modeling, we may need some additional USDA support to bring a full-time modeler on, like as a postdoc, to handle this as a particular project and help us get moving in that direction. Another thing that I think we will eventually end up doing at each of these sites is maybe putting these AMON, making them ammonia monitoring sites as part of the AMON group. So we're not only doing the passive samplers through Ogawa, but we're also using the AMON one AMON sampler as well, because it's a bit more pricey to get those in. I know I think April has switched to using just the AMON samplers and having all that work done by those folks. But to get it going on the other sites, we have to maybe scale back our budget a little bit and just use the Ogawas. So that hopefully will give you an idea where we're going. I think we'll have much more interesting information coming out about how livestock systems may be emitting ammonia, but how locally some of that ammonia is being recycled back into animal production via the local crop production of the sites. So it's exciting to kind of be involved in this. I was a little nervous about taking on this responsibility, but it's kind of fun to see how a group comes together and starts building a project. if anybody has any questions, I'd be happy to answer some. We may have a little bit of time still.
Yeah, we're okay on time, Dan. I'd love for, I have a couple of questions myself if the team doesn't come up with them on their own, just to follow up. Let's open this up.
And feel free to drop something in the chat or pop off mute.
Yeah, Joyce, you had dropped something in the chat around the study that may have been withdrawn. I'd be interested to follow up on that. And I see a hand from Brett. Go ahead, Brett. You're on mute.
Thanks. Well, I only caught the second half of your talk, but boy, this looks like some really exciting work. So my first question is, can I get, are you going to make this presentation available to the group? Because I'd really like to get to study this a little bit more.
Yes, I'll ask for the study and I'll link it to our website and share it in the notes as well. So everyone will have access to this. Yep.
And if you have an opportunity to make any of this stuff available or integrate into the AMON network, I would certainly encourage that, because that'll make this data available to an even broader audience. And I think it's really special and unique among the AMON, which tends to be more of a very remote, not very, but more of a remote monitoring. And so getting this type of information could really help in many ways. You know, we're actually doing a lot of struggling ourselves with chemical transport modeling and assessing ammonia's role within the air quality environment. So being able to take these results and start to integrate them with the chemical transport model by John Walker, EPA, those guys, is another one of those things that you seem to be on top of, and another great idea. Just so now a question for you, because I missed stuff, so I apologize, but are you going to have actual deposition measurements? So are you going to be quantifying the deposition rate, or only the ambient concentrations around these facilities?
So we're going to use those ambient concentrations to in the stage model to calculate or estimate a deposition.
Okay.
We're not measuring it directly, but we're using that stage model to try and figure out how that changes through time and the various inputs.
So okay. By the way, I'm with the National Park Service. So I don't know if you can do this, but we really need some real deposition measurements, because I think our understandings of the deposition mechanisms have improved dramatically, but there's still room for additional improvement. And we have ambient concentrations around, but not having the actual flux to the surface makes it really hard to constrain, because we don't know the real emissions, we don't know the real deposition rates, and so it creates these two confounding unknowns, opposing unknowns, which really makes assessment difficult. If you could somehow figure out a way of doing some direct deposition measurements, and I know John Walker has some methodologies. April's actually using them in the Snake River Valley. That would be terrific.
Yeah, it was basically a balance of what sort of physical and personnel resources we have to try and get the project. But my initial thoughts were, why don't I just, is there some way to just collect that nitrogen out there in an easy way? And I think it would be very, very much stronger to have that confirmatory data as well. It's just a matter of finding the right technique and the right amount of labor to try and match that up. And
yeah.
The larger data. So it's a balance. It's a real balance. But I couldn't agree with you more. Direct measurements are, in my mind, are always better. For some reason, we seem to be steered towards this model method, but if there's a direct way that's maybe something that we can integrate, that's something I need to look into.
Yeah, John has been doing some stuff, and he's been actually, I think so there may be some place. How long are you planning on running these studies?
This would be at least a 3-year course of work. And the thought is that once we have these various techniques down, the various locations could go to other spots and take a look at like local, say from emissions and depositions at a cornfield or something else. So they'd be able to utilize these resources and know-how to look at other problems. So hopefully, you hope for a kind of a legacy of your research. This would be something that could have a legacy.
Yeah, and there's time and potential opportunities to add to this, right?
Yep.
Down the road.
Yep.
Okay.
Yep.
Well, thank you very much.
Yeah, thank you, Brett, for the question. And Dan, the response is Christy, I see your hands up.
Yeah. Hi, Dan. Thanks for your presentation today. And one comment, one question. Comment is NADP is working to change the passive element in the amon from the radielo to the alpha, which will get us some cost savings. So we expect that to hopefully be approved in the next year. So that might help your budget out if you're interested in making those sites official NADP AMON sites, which again, as Brett mentioned, brings that into a public, website database for use by many, many more people. And then my question is, are there still opportunities for other sites to join in? Looking at your map, there's a big hole in Colorado, and with all the research that folks in this state have done about
Collins, that would be good to bring them on board as well. So
yeah,
I hope that we can extend it beyond it. We really just wanted to focus on, can we get this working at 1 or 2 sites and then build from there? And I think we can. And I think with national program, our national program buy-in, they have funds that could help push projects to be established and understood. And then it's just a matter of finding the right cooperators to work with and the right location to work at. Certainly the site in Iowa he was out the door like a gangbuster, but then really got sidelined by all the agreements that he had to get in place with because there's multiple landowners there, and it became it became a bit of a muddle trying to get that done. But I would love to do sites there on the Front Range as well.
Okay.
Yeah.
Well, we have a BMP group that is meeting after this meeting, and it mostly comprises the Colorado producers. And I guess I would ask that group to maybe not today, but maybe in the future, have a discussion on whether, this is something that, anybody would be interested in participating in moving forward.
And honestly, if we have stakeholder support for this, particularly from the producers and anybody involved on the Front Range issue, and that kind of finds its way to the national program support level, they can make funds and direct some folks to help out on this project even more than what's happening now. So that's the stakeholder support is key for us.
Great. Thanks, Dan.
Thank you. Jim had a comment, agreed the value on the sites in Colorado. Group agencies, likely producers. We'll bring that up as an option. Dan, thanks for that.
Keep that in mind. Yeah.
And then I just wanted to note, Joyce had mentioned that the MIST, North Carolina, and the cancer study you mentioned have been withdrawn. I'm not sure if you're aware of that. So, Joyce, any background you have on that to share would be really important here. I want to make sure you have the best information that our group is aware of. So.
Yeah. There's been unfortunately some stuff in Nebraska, at least in the free press, about higher cancer rates that they're seeing in some of these locations. And every once in a while you see those studies and they're trying to relate it to odor, they're trying to relate it to compounds coming in the air. And you got to be careful about it. I understand. And typically with nitrate, you get the blue baby syndrome for sure is one thing that's really well established. But there seems to be a bit of some evidence kind of accumulating around specific types of cancers here in Nebraska.
Yeah.
But yeah, definitely.
Anything you have to share and update with the team, I just want to make sure we're all working with the best and latest. So feel free to share back, and I'll ask the same of Joyce to do that. Hey, I have two other quick questions for you, and you can either handle these on or offline if you like, but it has come up in some of our, you mentioned in one of those sites, there was some human waste processing going on, right? Some sanitation facilities or something.
Yep.
The output of those has been of some interest to some of our parties. So just to circle back, we would be interested, I think, in learning, what, if any, types of contributions that you might learn out of that. And then the last thing is, Christy got into this a little bit, but just making sure that our samplers in Rocky Mountain National Park and the area are, if they are compatible and that data is shareable on the same apples to apples basis, that we have that conversation. So I'm glad that that was brought up as well.
Very good. Very good. Well, I really do appreciate everybody's input and thoughts and comments. It only makes the research stronger when we get everybody's input.
Yep. Oh, and there's something from Julie here on the text. What are the types of soils you're sampling? What's the requirement on CIFO on the lagoon liner? Is Nebraska DEQ requiring the nitrogen in the water and the nutrient budgets? So
yeah,
if you want to address those quickly, we've got a couple more minutes.
But was that in the chat?
In the meeting chat, the last chat.
Oh wait, I got to go down to the final mess. Okay.
Yeah.
So the types of soil samples, you can do any kind of soil sample with this, because we end up taking that soil to the lab and we do some spiking in of ammonia and nitrogen and taking a look at how much actually can bind and how much is easily released from the different soils. So it's made to set up to look at a variety of different soils. At each of the, I'm not sure what the soil type is down in Texas, but it's probably a silt loam soil for I know it's silt loam for Clay Center, and it might be a similar kind of a silt loam, highly organic soil there in Iowa as well, is what I would guess. So we don't necessarily have a whole lot of different soils represented in this initial study. So that's why it'd be nice to bring in the front range site as well.
Right.
Weather requirements on CAFO on lagoon liners. Yeah, there are a couple CAFOs that have been grandfathered in without liners. And I've been involved in some studies looking at nitrogen plumes coming off of those types of systems. Everything new in Nebraska, of course, requires liners and certain permeability levels. The lagoon there in Bushland, Texas, it is not lined. It's a natural sort of system. So yeah, it's an interesting, unique sort of way they handle their waste down in Texas. And maybe there's somebody here who can talk more on that better than I can. DQ require the nitrogen and water in the nutrient budgets. I believe it's part of, if you find yourself in one of these groundwater management areas with high nitrogen, and as one of the, I think there may be somebody who could actually talk to this better than I can, but I think there is, you have to account for that nitrogen coming out of the irrigation water as part of your nitrogen application. But I think it only happens in the areas that have the high nitrate problem. It's not statewide. That's how I understand it. I could be wrong about that, but that's kind of what I think happens.
Thanks, Dan. Dr. Alverman had a couple of comments in the last. Yep. So we'll just share that. Again, feel free, when I send out the notes, feel free to follow up with any additional information with the team. We're always looking for that. You can send it to me as well, and I can post those onto our site. Okay. And I'll look for that presentation from you. If you can email me that today, I'll get it out with the notes.
I'll do it right away.
I just wanted to add just a couple of things. So just
Go ahead, Bonnie.
Colorado has liner requirements and has since the 70s. So I just wanted to put that out there. So we don't have any online impoundments here that got grandfathered in. And then Texas also has seepage rate requirements. So even though it's a playa lake and it's in situ materials, it has to meet that seepage rate. So while it is an in situ material, it has to meet certain standards. So just wanted to add that to the conversation.
Thanks, Bonnie.
Good.
All right. Thanks again, Dan. Appreciate your time and the information. We'll follow up via email and keep you in the loop. As you learn more, please share that back with us at our next quarterly, if you like. So. All right, folks, let me share my screen again, and we'll get back to our approach here. Dr. Alberman, we'd had 10 minutes for you if you wanted to provide any updates on the latest research. I know you had sent out a note to the smaller group. I can bring that up if you want to talk through it real quickly, or whatever you're comfortable with. I know you're on the road.
No, I'm stationary and not posing a threat to anybody on the highway, and I am prepared to share my screen if permitted to do so, sir.
Oh yeah, love it. Okay, let me get you ready. You're now a co-host. Go ahead.
All right. Okay, you should be seeing a table. So I'm going to come back to that table in just a moment. So
Yep,
to reset,
you're good.
Everybody, am I coming through loud and clear, Brian?
Yeah, you're good to go. Keep going.
Okay. What we're trying to accomplish here, first of all, is to replicate the initial findings of the Gallus 2011 thesis, in which using sprinkler dust control water to suppress ammonia emissions was advanced as a possible BMP and slightly documented within that thesis. I don't mean to slight the thesis itself. I'm just saying there wasn't a huge body of highly controlled research that we can lean on. But it was an experimental design that we wanted to try to replicate and improve on as best we can by way of, eliminating confounding factors and so forth, to come back and say, did the Gallus thesis advance something that's plausible? And what we're showing here are composites of multiple 1 meter by 1 meter square flux chambers loaded with synthetic or simulated, I should say, feedlot surfaces. The red chart that you're seeing there, the measurements here are ammonia flux. It would be in mass per unit area per unit time. At time 0, then the lid goes on this chamber, and we're measuring concentrations and the flow through the volumetric flow of sweep, what we call sweep air, through the chamber. And when you multiply concentration by the volume flow rate of air, you get, roughly speaking, an emission flux once you divide by the area of the emitting surface. So anyway, that's the flux is what we're interested in as a source term in dispersion modeling. And so what we'd like to be able to find out is, can we effectively reduce, even for a temporary time, the ammonia flux from a cattle feedlot surface by sprinkling water on top of it? Now, there are a lot of different conditions under which this might be thought to apply. We're starting with a dry surface. The red is a background measurement. So this would be what would be naturally emitted by the dry feedlot surface. The light blue, let me go to the dark blue first. The dark blue is labeled SPKL, and that refers to sprinkling by hand using a watering can, the equivalent of 5 millimeters of water over the entire 1 square meter surface, and then closing the lid again immediately, and tracking the ammonia flux from there. And then in the light blue, we're applying the same amount of water, but we're pouring it on in a spot that is similar to a urine spot that would be created when one of these beef cattle would be urinating on the feedlot surface. There are other reasons for that light blue one. I draw your attention mainly to the dark blue one because that is the question addressed by the Gallus thesis. And you can see that on day 2, when we apply this 5 millimeters of water by sprinkler on manure sourced from Texas in an in vitro experiment, we do get a substantial decrease in ammonia flux for a period of time. And if you look on the far right here, 15% less cumulative flux from day 2 to day 6 as a result of using the sprinklers. Now, this is preliminary data, and it's also using Texas manure under highly controlled conditions. Now, we thought, well, okay, that's also using Texas water, by the way. Just recently, we went up to a feedlot in the Colorado Front Range, south of Greeley, and picked up some manure there. They finally dried out late summer after that ungodly spring that we had in the high plains, and picked up some manure there to begin a second set of virtually identical experiments. Again, the red is the control, where the manure is dry and emitting as it would if it were out on the feedlot surface. Dark blue is again the sprinkler. And you can see again, in Texas, the Texas manure was 15% less cumulative emissions. In other words, 12% reduction in cumulative emissions from day 2 to day 6, 12% in the Colorado experiment. So they're in the same ballpark. I like what we're finding. You may have noticed that the ammonia flux from the Colorado manure is substantially higher numerically than it was in Texas. So let me go back to that. And again, these are in vitro experiments. So the peak flux here in the control was about 500 milligrams per square meter per hour. In Texas, it was about 225 in the control. Same units. So Colorado, Texas, and shortly we'll have, once we're confident in our data and troubleshooting and all of that, I'll ask Mr. Lee, who's our graduate student, our PhD student working on this, to put the Texas and Colorado charts on the same graph so that everybody can make those comparisons more easily. Now, I do want to point something out, and that's where this table comes in. Ignore the words "as fed." That's really as is. And the moisture content, organic matter, and ash are all on a wet basis here. So they add up to 100%. Those three numbers add up to 100% in each case, Texas and Colorado. You can see that the total nitrogen in Colorado was lower, but the ammonia nitrogen was higher. That is, the organic nitrogen, in order to become ammonia, would have to break down in an enzymatically catalyzed set of reactions to get to the inorganic form that's then released to the atmosphere. Anyway, the point here is just that the two manure sources behaved differently, and we think we have pretty good reasons for that based on the analysis of the manure. There's higher moisture content and higher ammonia form or inorganic nitrogen in the manure itself, which means the pool of immediately volatile nitrogen was higher in this particular bulk manure sample from the Colorado feed yard than it was from an equivalent manure sourced from Texas. Let me stop there. I think we've got a question.
Yes, sir. Dr. Haverman, was there any significant difference in ammonia volatilization from day 0 to 2 post-sprinkling?
Post-sprinkling.
I'm sorry. I'm looking here. Your water application was on day 2, wasn't it? So
that's right. That's right. That's right. And so you can see there is some variability in the first couple of days between the treatments. I mean, we don't have 12 chambers that we can run simultaneously, so we have to run these experiments serially, if you catch my meaning there. But the point is that we can sort all of that out in numerical analysis looking backwards. And I think the results will end up showing, that 10 to 15% is achievable in this 4-day period after sprinkling. Now, what do we do if we sprinkle again on day 4? How does it happen further out, further out? What about well-aged material that's already emitted so much? What happens if you have an upslope condition that's reported or forecast, and the corral surfaces are moister than the conditions that we're using? All of those things are excellent questions, and we simply don't have the time and budget to answer them all, but that's what we're going after. Bonnie, you got a question.
Yeah, I just in looking at the 2 graphs, I see that there is that much higher spike right at the beginning, but then it looks like it levels off. When it levels off, the Colorado is lower than the Texas at that equilibrium.
And
I'll make sure I'm looking at that right, I guess.
that's an astute observation, Bonnie, as usual, and it's also traceable again to the fact that at least possibly, I would say the scientific rationale for that is supported by the fact that so much of the nitrogen, comparatively speaking, in the Colorado manure is in the already volatile form or pre-volatile inorganic form. And in Texas, more of the nitrogen is bound up in this organic fraction that would have to go through these enzyme-mediated reactions to become the inorganic fraction that would then be lost. So it gets lost faster and more completely in short time frames because it's all more of it is in that fast reacting pool. Does that make sense? I see Brian nodding his head anyway, so it makes sense to somebody.
Yeah,
I'm following. Bonnie?
yeah, no, it makes sense. But then it also still looks like we're still getting a higher emission over a longer period of time, but I see what you're saying.
So this is not the last word. This is an attempt to establish the plausibility, and it's in highly controlled conditions, in vitro, controlling everything that we can that would otherwise be confounding. And we've got several, I'm not showing some of the other 1 week long experiments where we're trying to sort out some of these confounding variables. We also have a treatment wherein we're applying the same amount of liquid in the form of synthetic urine, that is pure water that has been adulterated with a known cocktail of what is in cattle urine, but again, in a highly controlled fashion so that we know how much nitrogen is being applied. And of course, you get an ammonia spike associated with that because that's where most of the ammonia comes from anyway, is those urine spots. But all I'm trying to show here is the plausibility. I think we're going to be able to establish the plausibility of the Gallus conjecture out of 2011 and be able to enrich our scientific understanding of what is possible practically. Now, I mentioned that this is highly controlled in vitro work. The next step is to do some field commercial scale demonstrations using a laser-based technique. If you imagine that block in the middle, I wasn't able to download all of the graphics because of the bandwidth on my phone here, but if you have wind from the from the south-southwest here, and you have a laser in the dark blue upwind of the feedlot and another identical laser downwind, measuring simultaneously, and then you apply a treatment to the feedlot that's in that gray block in the middle. The idea is that you would show a change in the relative difference between the downwind concentration and the upwind concentration before and after the application of water. That's really the basic idea in the field scale demonstration. That will be demonstration quality data, not publishable quality data. But we hope to be able to show that what was possible to show in the laboratory does manifest to some extent in the field. Do I think we'll achieve 15%? I doubt it. But under very highly controlled conditions, we can detect up to a 15% difference. in 4-day accumulated flux following a sprinkler event.
Excellent. Yeah, really good stuff, Dr. Overman. If you can share that PowerPoint, I'll make sure we include it in our notes as always.
I will certainly do so.
All right, well done. I'm going to just share my screen again. We have a couple other thoughts. Dr. Schumacher's on, I think. Do you want to just give us a quick update on where we stand with the data timeline? I know we don't have new information today, but maybe just give us a little preview of what's coming.
Sure. Yeah. I think the NADP data, the last I checked, is only through I think January, so there's not really anything new to report because the winter is not the interesting time. The interesting stuff will come when the data is all processed from the extremely wet spring and summer. So that'll on the Front Range. So that'll be the interesting time to look at when that data becomes available. Let's see. Yeah, and I guess the other update in terms of the early warning system is the year of funding we had from CLA is over now. So we, are kind of back to just like status quo. The stuff is running. I'll give the kind of summary that I give every time. Like if we want to keep status quo, we could certainly, kind of keep things running the way they were over the last year. The small amount of funding, like what we received from CLA, would be needed for that. If we want to do something bigger and scale it up, that clearly is a possibility, but needs even bigger funding and doesn't necessarily need to be me. So I'm always happy to hand this project off to somebody else if they want to take it and run with it, because we've kind of gotten to where we can do things with the the resources we have and the fairly simple setup we have. But there's plenty of groups out there that could do something a lot more sophisticated if the resources were there. So that's sort of where things are on that end.
Perfect. Thank you very much. Yeah, we want to continue if we can to support all the great work you've been doing. So thank you. All right, that brings us to sort of the conclusion of our sort of the front part of our meeting. Unless there are other comments or questions, I'll pause to capture those. If not, then we'll move into our BMP working group mode as a next step. So I'll just pause. Any last bit of updates for the full group? All right. Thanks to everyone. If you're not on the BMP working group, please feel free to leave. If you are, we're going to dive in. We got some great updates from Dr. Overman and some research links and so on that I know everybody's interested. So that will be our next order of business here. And at this point, I will, as is our case, I'll stop the recording as well because we've agreed that's a working group and we want to keep that fluid and candid, those discussions. Thanks, everyone.
Thanks,
I will send
everyone.
out. Oh, yeah,
Good
go ahead.
Yep. Thanks, everyone. Good meeting.
Yeah, appreciate it, Christy.